Welcome back to the third installment of the AP Chemistry Chapter 7 Covalent Bonding Problem Set Review 2012. Mr. Wilkosz here. Let's check out 37. Okay, so we're given a number of different structures to consider, and we have to find our ideal bond angle. So the strategy for this is to draw the Lewis structures and then assess those Lewis structures. For this first Lewis structure, we've got a central sulfur and four, quote, items, a bond to chlorine, a pair of electrons, a bond of this other chlorine, and another pair of electrons surrounding the center atom. So with four things in the center atom, that's a basic geometry of tetrahedral. So the actual geometry of this thing, the molecular geometry, will be bent, but the ideal bond angles for those atoms should be 109.5. For xenon difluoride, the bond angle there should be 180 degrees. We've got these three pairs of electrons that are around the equator, and then the fluorines that are connected to the center will be going up and down. For part C, I threw a bunch of them in there. For this carbon, it's got 1, 2, 3, 4 connections, so it should be 109.5 degrees. For this carbon right here, there's 1, 2, 3 connections, so it should be 120 degrees. And for this nitrogen, there's 1, 2, those are the electron pair, 3, and 4 connections, then 109.5 tetrahedral there. Check out part D. Not sure why I thought it was 180. Anyways, let's take out part D. We've got a carbon with 3 connections to it right here. 1, 2, 3. 120 for this carbon. Another carbon here with 1, 2, 3 connections. 120. And this carbon has only got 1, 2. So 180 as its ideal bond angle. Let's take a look at problem 43. In problem 43, you're considering the ones from number 31 and trying to decide which ones are dipoles. So I threw back 31 up here so you can see what the structures are. And the key for this one is to look for symmetry. So you want to look at the central atom and decide which things have symmetry. Only A is a dipole. Everything else has some kind of symmetry to it, some sort of like arrangement that cancels out the pull opposing in opposite directions. This one does not cancel the pull because if you look to the left of the central carbon, there's a sulfur, and you look to the right of the central carbon, there's an oxygen. So it's an unbalanced set of forces. But with this structure here that's linear, there are balances. Up is bromine, down is bromine, and on the equator are all electrons that cancel out the pulls. Same sort of phenomenon for part D and even for part C. So they are not polar. They are not dipoles. Let's take a look at 49. For question 49, you're asked what the hybridization for the atoms in number 31. So for this one, gotta take a look back. At the structures here for 31. We look at the central carbon, there are 1, 2 unique connections, so it should be sp hybridization. We look at the central iodine for part B, there's 1, 2, 3, 4, 5 total things around it, so sp3d to get to 5 orbitals. Look at the nitrate, 1, 2, 3 unique connections, sp2. And if we look on the radon in the center here, 1, 2, 3, 4, 5, 6, with 1 and 2 being these pairs of electrons, so that's sp3d2. Take a look at number 61. You're trying to give the hybridization for the underlying atoms. Ideally, you draw out these Lewis structures and see that, but I want you to try and practice this. This is one that's already showed up a few times, so go back to your previous ones and check it out. But I'm saying, hey, it's going to be sp2. The nitrogen in nitrous acid would be sp2, and this carbon right here, if you drew this out, would be sp3. The connections being to 2 methyl groups here, 1 to a hydrogen, and 1 to this other methyl group listed at the end. Finally, 69. You're considering vitamin C and asked to kind of assess this particular molecule. First, you're being asked to look in how many sigma and pi bonds are there. So if you go and count through this whole structure, it's kind of a nuisance, but you can take your time and do it. It's 20 sigma bonds and 2 pi bonds. The 2 pi bonds are easier to pick out. Right here, one of these 2 bonds, and then right here. This is sort of an abridged version of vitamin C as well. So to get your number of unshared electron pairs, you have to kind of count where there's not fully 4 bonds. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Angles in hybridization are the same as the last couple.